Good morning, world. Paul Whittakin back with my Universal Law of Numbers, periodic table of mathematics, and we can talk about it as a periodic table of numbers as well. So the first thing I want to do today is I just want to point out that if we were to put a negative sign in front of any of those numbers, it would work as well. If we were to make them into fractions, for instance, 1 over 1, 1 over 4, 1 over 9, 1 over 2, 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5, 1 over 6, etc., it would result in the same exact numbers as fractions. So what it is it's a circle, and it's an infinite circle. It can be the tiniest circle that you can imagine, and it can expand out to the largest circle you can imagine. And if you want to picture that, you can see that it's a cone as well. Even if you plot the dots on a Cartesian plane, you will find that you can recognize a cube structure in it. So it takes many different forms. Now, what I'd like to do today is just briefly review the codes again, because the codes are the key. And in essence, there's really only one code. It's the 369 code. And as I point out often, we don't see any 3s or 6s in it, but they're there. And we have one code in particular that I point out, which is the next code, and I call that the 248751 code. And in essence, these other subcodes are in reality the 248751 code, but the 248751 code is the 369 code, because what's the number between 2 and 4? It's 3. What's the number between 5 and 7? It's 6. What's the number between 8 and 1? It's 9. So just like it obeys the properties of addition, of course it obeys the properties of multiplication as well. So I will try and point that out a little bit. 2 times 4, well, 2 times 2 is 4. 2 times 8 is 16. 2 times 5 is 10. 2 times 1 is 2. Okay, so what about 2, 8, and 5? Well, 2, 8, 5, it's a 3 and a 6 code. Let's call it like that, because between 2 and 5 is 3, and between 2 and 8 is 6. Now, the 285 code and the 741 code, if we put them together, they're the 248751 code. Even the 818 is part of the 248751 code. 8 is separated by 2 to 1, separated by 2 back to 8. 285, separate 1 to get to 8, separate 1, skip 1 to get to 5, skip 1 to get back to 2. 741, well, we can call it 471 or 174. 1, skip 1 is 4, skip 1 is 7, skip 1 is back to 1 again. So we will just go, okay, so now we'll do 4. 4 times 4 is 16, skip 1. 4 times 8 is 32, skip 1, you get a 5. 4 times 5 is 20, skip 1, you get a 2. 4 times 1 is back to a 4. And 4 times 2 is an 8. What about with the 8s? 8 times 8, skip 2, is 64, it's a 1. 8 times 7 is 56, skip 1, 2, 3, you get a 2. 8 times 5 is 40. 8 times 1 is 8. 8 times 2, 16. So it works with all of the numbers just the same. 7 times 7 is 49. That's a 5. 7 times 1 is 7. 7 times 2 is 15. That's a 5. 7 times 4 is 28. That's a 1. 7 times 8 is 56, and that's a 2. So you can do it with all of the numbers. They're always going to work out, and there's a reason for that. It's very simple. Of the numbers 1 through 9, the only numbers that are not 3, 6, and 9 are 2, 4, 8, 7, 5, 1. But they're basically, they're working together to become a 9. Let's look at the 285 portion of the 2, 4, 8, 7, 5, 1. So I mentioned before that 2 plus 6 is 8, plus 6 is, 2 plus 6 is 8. 8 plus 3 is 11, which is a 2. 8 plus, basically what it is, it's 2 to 8 is 6, and 2 to 5 is 3. So that's the 3, 6 that comes into play. And if we go 2 to 5, it's plus 3, and 5 to 8, it's plus 3. So it's 3s and 6s built in. 7, 4, 1. Well, 1 to 4 is 3, 4 to 7 is 3 as well, 1 to 7 is 6. Okay, so let's do a little multiplication on this one. 2 times 8 is 16, 7. 2 times 5 is 10, 1. 8 times 8 is 64, 1. 8 times 2 is 16, 7. 8 times 5 is 44. So the 285 and the 741s are basically their intervals within the 248751 code. And that's all I can think of right at this particular moment with that. Other than the fact, really, when it comes to this kind of arithmetic, I encourage everybody to do it themselves, and they will gain the insight that you derive from that. Now, counting is a very important part of science. If you ever study chemistry, for instance, you will find that it's just one big, very fancy, complicated form of arithmetic. You're always counting things. You're counting electrons and protons and neutrons. You're counting charges. You're reassembling them, and you're putting them into entities, and we're calling them atoms, and we're calling them molecules, and it's all just one sophisticated kind of counting, arithmetic. And when you study this code, you will develop that skill, because what we're doing here is we're not only adding the numbers or, showing the patterns, because that's really what it is. That's the whole point of the exercise, is to understand the patterns of the numbers, the way they interrelate with each other, which are never coincidences. But we look also at the difference between the numbers, the difference between 1 and 4, between 4 and 9, the difference between 4 and 8, and the difference between 8 and 7. And by doing so and peering inside of it, then up pop the other numbers, and they all follow the patterns. So when it comes to mathematics in general, it's all well and good to memorize tables. You memorize multiplication tables, you memorize equations and the like. But the key is not so much that. The key is to recognize the patterns, because they will always, the numbers in sequence will always be following certain patterns. And if we recognize those patterns, then we gain the understanding of what's underlying underneath. Okay, so now I will go back a little bit and talk about the circle, which, I brought up last time. And, I pointed out that the circle is following a 369 code, which obviously it is, because it's 360 degrees, and 360 is a 36, and a 3 and a 6 is a 9, and 3, 6 equals 9. So 360 degrees, it will always, abide by the 369 code. So we just see it, 369, 369, 369, and that's if we divide it up that way by 30-degree integrals. But if we divide the circle up by 30-degree integrals, then we're really having 12 parts, aren't we? But in reality, I think it's, and that works just as well when we divide it up into 8 equal parts and do them 45 degrees apart. Okay, it's still going to be 9, and the circle is, in a sense, it's shouting out at us, hey, I'm a 9, because I just showed it with you, dividing it up into 12 parts. Now we've divided it up into 1, 2, 3, 4, 5, 6, 7, 8 parts of 45 degrees. Well, 45, 4 and a 5 is a 9. And if we want to do it with the pi or whatever, essentially when you're using pi, you're just dividing it by 180 degrees, aren't you? Because that's what pi is. So, if we divide 30 by 180, that's going to be 3 over 18. And that's going to come out to be a 9 if we multiply, right? If we multiply 18 by 3, we're going to get 54, which is a 9. If we want to do pi over 2, we can call it 9 over 18 pi. And anything that's multiplied by the number 9 or a sequence of the number 9, which 18 is, it will always reduce to a 9. So here I have it 30 over 180, 90 over 180, 135 over 180, 1 and 3 and 5 adds up to a 9. 180 over 180, that's fair. That's 9. 225 degrees, 2, 2, and 5 is a 9. 270 over 180, well, 2 plus 7 is a 9, as well as 1, 8, or 9. And 315, 315 degrees over 180, and 315 is a 9, and 180 is a 9 as well. So that's when we divide the circle up in 45 degrees increments. Okay, so I'm just going to show it to you without that, but if we just do 45 degrees, 90 degrees, 135, 180, 225, 270, 315, once again, the thing is shouting out at us, hey, I'm a 9. Okay, and I believe you. I can accept that. All right, so I like to look at it like that. And, I'm just showing the one that I pulled up the other day, I think. And we go pi over 3, pi over 6, pi over 2. This is the conventional way of doing it. And then you can turn it back into a 369 if you like. But you could just as easily turn it into 9s or 3s and 6s and 9s or 6s, 3s, or 9s. But the bottom line is, it's a 9. Well, we call it a 360-degree circle, and I accept that. So, once again, I took the codes and I just connected the lines, and by doing so, we see the 369 sequence there as well. So that particular 369 triangle, well, we could make it using any of the increments that are 3, 6, 3, 3 apart, right? Because if we started with, 8 and 5 and 2, you're going to get the same thing. 7, 4, and 1, you're going to get the same thing. And that's where those codes are coming from, because in actuality, the universal law of numbers is describing a circle. It's revolving around. It goes from 1 to 9 and starts back up at 9, and it revolves around and around and around. So I'll just show you the 741 code. and I'll show you the 528 code again. Okay, so that's how we understand those to be such. All right, and now I will start to, basically we're going to look at the 248751 code. All right, so, you know, there's triangles, there's rectangles, there's a structure there that's very symmetric, and you know, I did it around the 9, but if we look at it, it's a 3, 6, 9 sequence, because 3 is not connected, 6 is not connected, and 9 is not connected. So the fact that it's not connected makes it just as much of a 3, 6, 9 system as being connected, because in a sense it's the opposite of the 3, 6, 9 triangle here. Okay. So what I did with this one, and I'm just showing these, I did them a little bit different this time because I actually used the 9-sided, the 9 points on the circle. Well, when we divide the circle up into 9 points, they're going to be 40 degrees apart. And this is what, you know, the diagram looks like with the 2481, well, really, the 528, the 741, and the 181, plus the 369. And that's the geometric structure that we arrive at when we connect those lines. This would be the periodic table of numbers just by itself. So that's what that diagram looks like, and, you know, how to describe that exactly? Well, it's one of those optical illusions. You know, it's very hard to keep your eyes targeted and concentrated on one particular object, but inside of that object, you know, you could see a pyramid structure if you like. You can see many different kinds of structures. And it's just as interesting if you turn it, you know, in different directions, which I'll do for you. So it just depends on how your eyes are focusing, really what you get. So the next one will be the periodic table of numbers, and I'll use all the codes, including 248751. Okay, so now we get an even more intricate geometric structure, which I referred to as, you know, a multi-dimensional pyramid structure in space, because it has many points. It has actually 1, 2, 3, 4, 5, 6, 7 points. Right? Okay, 1, 2, 3, 4, 5, 6, 7 points. All right. Okay, the only numbers there that are not connected are the 3 and the 6. So then I just added the 3, 6, 9 on top of that, and I actually enclosed them inside of the 1, 2, 3, 4, 5, 6, 7, 8, 9, added them into the picture, and so I would encourage you to get your kids out with their crayons, and they could make this diagram themselves. You just basically give them the universal law of numbers and have them apply the codes, and they can connect the lines, and they can color them as they please. And if they were to do that, then I think you would see some very interesting geometric structures, you know, standing out inside of them, inside of this diagram. So Whatever it is, I referred to it as the shape of the universe. Hey, I don't know what the shape of the universe is, but it's the shape of this universe for sure. Okay? That's the shape of this universe. And this universe comes to me and all of us from the real universe. So I like that. And this one here would just be the periodic table without the codes, but connecting them together inside, by the 1 through 9. Now, we're led to believe that we live in an expanding universe, and this creativity here does not contradict that at all. I mean, the universal law of numbers, the periodic table of numbers that I refer to here, has infinite, it goes to infinity. It goes to infinity in the negative direction, and it goes to infinity in the positive direction, and it's always getting larger and larger and larger, and it never stops. There's never a finite point. It just keeps going on and on and on. So that will be our lesson for today, and I hope to see you back again soon.